Okay, who would like to say our opening prayer?
I can say it.
Sweet.
I'll say it.
Awesome.
Our Heavenly Father, we're so grateful for this day. We're so grateful we could get together and meet as a group and teach each other what we're learning. Bless that we can have thy Spirit to be with us, and bless present Monson Father and those who serve with him, that they can remain healthy and strong. Bless that we can have thy Spirit to be with us, and say these things in the name of Jesus Christ. Amen.
Amen. Okay.
Party tonight.
Fun. Okay, so we have anybody have any questions on the part of the preparation?
Well, it says we're supposed to do it together. I didn't see that.
Yeah.
At first, and I got through to I think 7B.
Okay.
I think I understand everything pretty well. Should we go through it together? Since it says
go through it together.
Yeah, it says you'll complete part 2 with your group.
Let's do it then.
Okay.
Okay.
I'm pulling my document up.
Okay.
Awesome.
But you guys can start.
Okay. So for number 7, confidence interval. If in an October 2008 poll, 684 out of 1,006 randomly selected college students reported that they had been involved in an automobile accident within the last 5 years. So A is find the proportion of those surveyed who have been in an automobile accident in the last 5 years. So that is, the proportion is at the
I think that's the number of people who reported they'd been in it over the randomly selected college students. So
yeah,
64 out of 1,006.
Okay, get it.
Mm-hmm.
And so I got 0.680.
Oh yeah, round it up.
Or 0.6799, and that's how they wrote it in the answers.
Yeah.
Yeah, that makes sense.
Yeah, it does.
Okay.
Sorry, I'm just getting my thing pulled up.
Okay.
So we're all in agreement there. Okay, so check requirements in constructing a confidence interval for this data.
Okay. So I felt like N was 1,006.
Right.
Uh-huh.
And he was the 0.68. Yeah, so the proportion that we just calculated, the 0.68.
Yeah.
Okay.
And so the first, so that one, the sample size times the proportion was 684, which is greater than 10.
Yeah.
And then the other one was 1 minus p times n, 1 minus 0.68 times 1006, and that was also greater than 10. I didn't write it down for some reason. 321.
Oh, sorry.
Yay! Do mama. Mommy, do grandma.
What were you saying, Kelton?
Oh, I was just going to say, so in that case, the requirements are met, right? Both of them are greater than 10.
I think so.
I agree.
I think.
Nope. Alright, hello, burger. Hot Mom. Hot Jamie.
So, okay. So yes, the B is okay. C, determine the margin of error for a 95% confidence interval based on
I don't like
data.
it. Get out.
Okay, so we need to find the margin of error.
Do you have that formula?
I think it's
Yeah, very dry.
that one's M equals Z times the square root of P times 1 minus P over N.
Yeah, that's what I have too.
Okay, cool.
How about there?
And they did say something about a 95 confidence interval in the lesson. Oh, and it says in there. So Z could be 1.96, right?
Uh-huh.
Yeah.
And then I was confused about what P should be because it wasn't P caret, it was just P. But in the lesson it said that we could assume they were the same.
Right.
Mm-hmm. So I think the P is the 0.6799 or the 0.680.
That's what I think.
Okay.
But they always put it as 4 digits, so I don't know if we should do that too. 0.6799.
I think the 0.6799 will work. But I'm not sure.
Okay, I don't know if this is just me, but I'm putting those numbers in. I'm doing those numbers with the equation, and it's not pulling. Hold on, I might be looking at something else. Never mind.
Okay. At first, I tried to use the Z-score formula for some reason instead of the margin of error formula. And obviously that one would come out as 0.
Mm-hmm.
Oh, I wasn't square rooting it. That's the problem.
Oh,
So I think what it should be is like 1.96 times the square root of 799 times 1 minus 0.6799
Okay, yeah, that's what it is.
divided by 1006.
yeah, I just remember that it's 1 minus 0.6799 inside the parentheses.
No.
And then you always do the parentheses first, right?
Right.
Or does it matter? Okay.
It does. It
Cool.
does matter.
Okay.
So
Mama, take that. Mama, take that. Hey, water.
So I got a 0.029
That's what I got.
yes,
or 0.0288.
Mm-hmm.
Yeah.
Yeah.
So another way we could do it is if you do that Excel file that it has us open, the one sample z-test for proportion, it gives us the confidence interval there.
Oh, good idea.
So you could just subtract or add that one of those to the p, and it gives you the
Right.
same.
Okay.
It did give us a new formula too, though. Not much different, but.
Yeah.
Mm-hmm.
So that is another way.
Oh, okay. So the margin of error formula, and I knew this from the last time, but I've forgotten it. The margin of error formula is the one that we use to find out the interval. We just have to add it or subtract it from p, right?
Correct.
Mm-hmm.
Okay. So which file is it?
So if you go to it's the categorical data analysis _hat.
Okay.
So if you see, where was it?
I see it.
Yeah, it's under section 2.3.
It's in the help Excel tools, right?
Mm-hmm.
Mine's not loading for some reason. But for the lower bound, I'm getting 0.651.
Correct.
Does that sound right?
Mhm.
Okay.
Yeah, that's what I'm getting.
Yes.
The upper should be 0.709.
Mm-hmm.
Right, yeah. That's what I'm getting too.
Okay.
And
So
then
you
we're
said the one proportion test? Okay, I see that.
Yeah. So it's the one proportion one. So
Interesting. Okay.
okay. So we're ready to move on to also D. We were supposed to say interpret the 95% interval. So we are 95% confident that the true population mean P is between 0.6511 and 0.7087.
Right.
Mm-hmm.
0.7. Yeah.
Okay, so E, how many college students should you survey if you want a 95% confidence interval with a margin of error of no more than 0.015? Now this one, you cannot use that Excel feed.
Yeah. I was disappointed when I found it out.
I'm cheating, but I was, even before they had us use these pre-made ones, I emailed the teacher and I was like, am I allowed to use like formulas and stuff in Excel to do all this? And teacher was like, of course.
Okay.
I love that.
He meant to say,
So
of course,
for
idiot.
the
Okay, so our N formula is N equals Z over M squared, and that's times P times 1 minus P.
So should we be using the one where we don't know P?
Yeah, probably. Yeah, let's just do let's do them without P.
Okay, so N equals Z over 2M squared.
I think so. Hold on, let me see.
yeah, I think that's the right one.
Yeah, I think that's it.
Yeah.
That's
Nine,
what's
six.
is when we're supposed to assume we know P and when we're not. Because sometimes they say they're the same and other times they don't.
Yeah.
Yeah.
Okay.
Let's do that when we do it without it. So
Okay, so it's 1.960, right? For Z.
Yeah.
and our M is 0.288. 0288. And then,
Wait a second. So how did we find M?
Yeah, what is M?
Is that the
M is
margin
our
of
margin
error?
of error.
Okay.
Yes.
Oh, it's the top one minus the lower one divided by 2?
Right.
Yep.
Right.
Okay. Okay.
Okay.
And you said that was 0.0288?
Yep.
Okay. Oh, 0.0288?
0.0288. Yeah.
Okay. All right.
Oh. Wait, no, never mind. I'm sorry. The answer gives us, the question gives us the margin of error that we want, and it's 0.015.
Sorry, what?
The question told us what the margin of error was that they want us to have. Like,
Okay.
how many people do we need to survey to get that
Oh, I see
margin
that.
of error?
I see.
0.015.
Thank you. So 1.96 divided by 2 times 0.015,
Yep.
and then squared.
Yep.
Thank you for catching that. 4268.
That's what I'm getting.
Yep,
Okay.
that's what I got.
Mama, open it.
4444.
Mama.
Yeah.
Okay.
Okay, so we're on to number 8. Now you are interested in testing a claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above and use a level of significance of that thingy equals 0.05. Okay, so first question, state the null and alternative hypothesis. So our null hypothesis is going to be, I don't remember what you call that thingy.
You mean the
Whatever
HO?
Yeah,
Yeah, HO is null, right?
yeah, null hypothesis. So it's P equals 0.6, and then the alternative is P,
Oh yeah, okay.
or P is greater
The
than or equal.
proportion.
Oh, okay, yeah, P.
So then the alternative is P is greater than 0.6.
Right.
Take it down. Mama. Baby. Mama. Oh, baby. Mama. Mama.
So we just do the Z formula for this next part?
Yeah,
Can we plug it into Excel?
yeah, it calculates it for us.
Okay. So
Yeah, it gets it for us. So that's going to be, I'm showing, so plug in our X and our N, confidence level is 0.95, our null hypothesis is 0.60, and the type of test is greater than. Does that sound right?
yes.
Okay. And then all that information, a Z of 5.174.
5.174, is that what you said?
Yes.
Okay, sorry, you're breaking up a little bit.
Sorry.
It's not your fault, that internet. Wait, so is the p-value 0?
Yeah. P-value is 0. How about that? So, in that case, D, what decision do you make about the null hypothesis? Well, P is low, so we reject the null.
So over 60%
I will know.
have been in too loud. Go sleep. Oh, Kelton can't hear us. Did you guys get that text? That Kelton can't hear us?
I can hear you now.
Okay. So we're on E?
Yes.
Okay.
What is that?
Tyler, are you still there? Or your video cut out?
Look.
All right.
Okay.
Oh, he just got dropped.
I'll text him.
Oh, he's back. All
I'm
right.
back. Sorry.
Yay.
Oh, good.
My internet went down, so I threw on my personal hotspot on my phone.
Nice.
Oh, that happened to me last time.
Yeah. It's been spotty all night,
Brought
so
my
I'm surprised before, but we're good to go now. So I was I was like, can they just not hear me or are they ignoring me?
Oh, we wouldn't ignore you.
I was like, are we all on the same page? Are we ready to move on to the group quiz? And everybody just out there, and I was like, what the heck? So I looked at the.
I'm sorry. Okay, I'm gonna try and get rid of the little baby real quick. Come here. Let's go see. I'll be right back.
Okay, well, she's gone. Maybe you guys can help me with the question I have. So how do you
Okay.
know when
Okay,
to
what's-
reject the null or fail to reject the null?
So if the p-value, when we find the p, if it is lower than the alpha, which is the little squiggly, like the little this thingy that goes like this. If it's lower than that, then if it's higher than that, then we fail to reject it.
So if the p-value is lower than alpha, we reject it.
Yep.
Yes.
I just got dropped out. I'm back.
Sweet. Yeah, so the little saying is, if the p is low, reject the null. Null.
Okay.
Low.
And then if it's higher, reject it.
Yep.
Okay.
Okay, are we in the quiz?
Yeah, we're on the quiz now.
Okay, lesson 17, right?
Yes, ma'am. So many lessons.
I think everybody's internet is messing up tonight because I got kicked out too.
Well, shoot. Let's boogie. So is everybody in the quiz?
Yes.
Almost. Hold on, my internet's being a little funny too.
Oh. I know it's supposed to storm tonight in Kansas, but it's kind of been going over the whole country, so.
Yeah, we've got a storm here too,
I live in
and I'm
Arizona.
on the East Coast.
In Arizona. It's going to be 118 on Monday.
Holy cow.
Oh, no.
So
Oh,
we're
bad.
usually does that a couple of times a year. So
We're on lesson 17.
Yep.
Yeah.
We get up to
Sorry, I
100.
was on lesson 16 in another class.
Oh no.
Yeah.
Confusing. I hate it when that happens.
Oh, one time I posted to one discussion board about whatever I thought the topic was, and people are like, "What are you talking about?" And I looked again, and I realized I'd posted to the wrong discussion board in the
Oh,
wrong class.
Oh,
I had a full conversation with our teacher. Is it Greenlaw?
yeah.
Yeah.
Was it Greenlaw? I had a full
Yeah.
conversation with him. Like, I was like, hey, it wouldn't let me turn in the mini project this week. It just kept saying error 404, page not found. And he was like, are you talking about the group quiz or the homework assignment? And I was like, no, it's the mini project 4. And I kept saying all this stuff. And he was like, I don't know what you're talking about. I'm sorry. And then I looked and I was like, I am talking to the wrong teacher.
yeah, that's the Excel assignment, right?
My Excel class. So they're both deal like with, it's like, this used to be all one class, I think, the statistics and Excel. And so I get it mixed up sometimes.
It's okay, I do too.
Okay, so the first two we answer on our own. We can all
Mhm.
answer true to these, I believe. And then question 3, the symbol of the true population proportion is which of the following? I believe it's just the P by itself, correct?
Yeah, and the P with the caret is the sample.
Yep.
Okay.
For the estimate.
Yep. Okay, so for the next two questions, suppose n equals 100, p equals 0.25, and the sample proportion equals 0.1. So the first question, the requirements for constructing a confidence interval are satisfied.
Okay, so we've got to plug in those. Oh, can we put this in Excel? We don't have N, do we? And we have N.
We have N, it's 100.
But we don't
have.
We can
X.
find X because we have the P, the sample proportion. So we just work backwards. So it would be 100 times 0.10, which gives us 10.
Okay. And 10 is X?
Yes.
Okay.
Thank you.
Welcome. And so, and then on that sample z-test for proportion, it does give us that information. So I'm showing that 10 is greater than or equal to 10, and then 90 is greater than or equal to 10. So I say that's true.
Oh, okay, because this is for confidence interval.
Yeah.
Okay. Okay, so 4 is true.
Mm-hmm.
And then it's asking the requirements for conducting a hypothesis test are satisfied. I don't know. We weren't given a hypothesis.
Well, if you look at the box above confidence interval, it says 60 and 40.
But that changes depending on what your null hypothesis is.
Are you sure though? Well, what's the
Yeah.
formula?
Yeah, let's see what the formula is.
NP or N1 minus P. So we know what N and P are, so it shouldn't change, right?
Where is that one?
Okay, so in the lesson, in step 4, it says the following conditions are satisfied. Let's see. That's for a hypothesis test. Is that what it said, hypothesis test? Yeah.
Yeah.
So if N times P is greater than 10 and N times 1 minus P is greater than 10, then you're good for both.
Yeah, that is correct.
So all we need to know is N and P, and since they're in there,
Okay.
and it says on the one sample z-test for a proportion, There's a box for hypothesis test requirements and confidence interval requirements.
Yeah.
Mhm.
Looks good to me.
Okay, so so 4 is true and 5 is true.
Yep.
Yeah.
Okay. Number 6. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Find the sample proportion, the point estimate of the proportion of first-degree murder defendants who were found guilty in the state. So 60 is our N, which is our population. 45 is our X. So our P is
40, is it 45 over 60?
yeah, so that's going to be 0.75.
Okay.
0.50, which I don't think that matters.
0.750?
Yeah. And that does give us that on the sample z-test for a proportion as well. The P hat. I'm going to call that a party hat. Get it? Because it has a P over it, or a little party hat over it.
Okay, wait a second. I have X as 10. No, okay, so we have to change it. We have to change it, don't we?
Yeah.
45 and 60.
Yep.
Yeah.
Okay, now I'm on the right page.
Cool.
Cool. Yeah, I don't know what the hat part is about.
Hat. I think that's just the whatever that thing is above the P.
Oh,
Oh,
Carrot,
okay.
whatever. Yeah.
Okay, Suzette got kicked off.
Uh-oh.
oh no.
This whole week I've been having internet problems or cellular problems, you know, just
She's trying to get back on.
right. So if they don't give us any like a null hypothesis or confidence level, do we just assume or just leave what's in there?
I guess.
Yeah.
Okay. So what temple is that behind you, Tyler?
That is the Mesa Temple.
Is it? I thought. I was born in Mesa.
Oh, cool.
Were you born in Mesa
Yep.
too, Tyler?
I was born and raised.
Cool.
Still too. I'm at my girlfriend's house. I always do my things from here.
Oh, yeah?
Oh.
But she wanted a unique picture of that temple, so her dad took that picture and then got it framed real nice.
Nice.
Cool.
Yeah, it's a really cool picture.
Do you not have internet access at your place?
No, I do. I just spend more time here.
Nice.
It's more quiet.
Huh. Yeah, maybe I should try going somewhere else. I
I wish I could. My husband gets back on Saturday. We've been doing pretty good though.
That's good. And you said you live in Kansas?
I do.
Awesome. Kelton, where do you live?
I live in Boise, Idaho.
Oh, cool.
So, yeah.
That's awesome.
And Suzette's in Virginia.
Oh, nice.
Yeah.
So I thought it would be kind of cool to do a survey of us in our own counties for our project.
Yeah, that's gonna be cool. I just looked it up real quick today just to see see how it worked. And that's a good idea because it's not like it's a ton of work. The research is already there.
Right.
You just have to compile it.
Yeah. And then did you find out if one of us has to submit the proposal or all of us do, or
I wasn't
I
able
haven't
to.
had a chance to
wasn't
read
able-
it.
I'm gonna have to look at it again because I wasn't able to really. I don't really understand it.
Okay. Yeah.
Because
I'll look-
when I clicked on it, it was like a huge long thing, like the whole thing. I don't know if that's what he's looking for or what.
Was that to design the study file?
Yeah.
yeah, so
Okay,
that-
she said it's going to be a while.
yeah. She said she'll be a while.
So do we want to wait for her or what?
Let me ask her.
Stupid updates.
Yeah, for real.
My internet is really slow right now.
Mine too.
It's saying you should go online. I am online.
Yeah. Mine was really slow on Wednesday because I was using that mobile hotspot and we were all using my phone for the computers.
Mhm.
But the power went out here on Wednesday, and then the whole Wi-Fi went out on around our neighborhood. So
Okay.
Okay,
that's-
she said to go ahead.
Okay.
Okay.
Okay, cool. So let's just continue with the quiz and then we'll go over that design and study thing. So it says determine a margin of error for this 95%. Oh, wait. I forgot to read the information. Create a 95% confidence interval for the true proportion of first-degree murder trials in this state. There, the verdict is guilty. Input your answers for the margin of error, lower bound and upper bound. So determine margin of error for this 95% confidence interval. So
Is that the one we've been doing?
I think so.
Okay, so all we should have to do is check that it's a 95% confidence interval. We don't have to worry about a hypothesis, right?
I don't think
Correct.
so.
yeah.
For 95% confidence interval. Okay, the thing that's going to get me, I think, is the difference between the confidence interval requirements and the hypothesis test requirements.
Mm-hmm.
Yeah.
Okay. So I see the confidence interval as 0.64 and 0.86.
Point. Yep, that's it.
Mm-hmm. So that's the lower and upper bound, right?
Yeah.
So that's 8 and 9.
0.11.
Should be 0.11.
Not-
Who's breathing and I don't know what happened.
Where are you breathing? Oh, it's just an old card. So you're going to take me in the bathroom, but you're in your bed. Okay, sorry. I have a child who's bleeding. I'll be right back.
I need help. I don't know what I do. I need help.
Okay, sorry.
Okay.
So what did we say number 7 was?
I think we said, let's see. I don't know. I'm getting weird.
0.11? The upper minus the lower over 2?
Yeah.
Yeah.
Yeah, 0.11.
And we have to say 0.110, is that right?
So our lower bound is 0.640. And our upper bound is 0.860. Okay, number 10. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? Well, let's see. It got smaller. Wait, did it get smaller? Oh. It's pretty much the same.
So the sample size, is that X or is that the N?
That's the N.
Okay.
I didn't expect the lower bound to change so much.
Me either.
But decreased, is that right?
The confidence interval is pretty much, well, the numbers change, but the width of it stays pretty much the same.
Hmm.
When you define the margin of error for that new confidence interval, it's 0.108. And that's barely, that's 0.02 away from our,
But still smaller.
it is smaller. So do we want to go with decrease?
I think so.
Yeah.
Let's go with decrease. We got 2 tries. If it's wrong, we know which one it is. Okay, so question 11. To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1/2. What is the smallest N can be and both requirements still be met? So we had the same question the last one, and I got it wrong both times.
Yeah, I did too.
Okay, so if we used Excel, does that help us at all?
I don't know. Let's see. So if P, it's not even the P hat thingy, it's just normal P, right?
Right.
So the way we,
Yeah.
it's
Sorry, go ahead.
thinking out loud.
Well, you were telling me that we could find out what X is.
We can find out what X is. How do we find out what P is?
You mean what N is?
Well, it's asking for the what is the smallest N can, oh, and both requirements still be met. Yeah. We
So
have
I'm
P hat. Is that still okay?
Yeah, so we can substitute them. If we have P, we can assume that that's P caret P hat.
Oh wait.
Formula.
So what's the formula? What's the formula for a hypothesis test requirements?
Well,
That's the
formula for N is Z over M squared P 1 minus P.
so
So section 3.1.
oh. Well, we don't have a margin of error.
Okay.
So if P is, let's see. If P is 1/2, that has to be greater than or equal to 10. So what could N be to still be to equal 10? So it's 10.
Okay.
20.
Okay. Same.
So 20 times 0.5 equals n. Yeah, so the smallest n could be 20.
Okay. Because that equals 10.
Yeah.
And
Or 1.
right, that makes sense.
Yeah.
Okay.
Yeah. How'd you get that answer?
So the equation to find the hypothesis test is, or the two requirements are NP is greater than or equal to 10, and then N times 1 minus P is greater than or equal to 10. So I plugged in P, the 1/2, divided that by 10, or 10 divided by 1/2, and that gave me what my N had to be.
Oh, wait. Say that again.
So I did like the equation would be N times P equals 10. So I plugged in the P, N times P 1.5 equals 10. So then I divided 10 by 0.5, and that gave me 20. So, and then I just plugged it in together to make sure that worked. So 20 times 0.5 equals 10. And then 1 minus 0.5 times 20 equals 10 as well.
Okay. Cool.
Taking me back to sophomore year of high school.
Yeah, I didn't think to try it that way. I just plugged stuff in for N.
Yeah.
Yeah.
But now
that
the
makes
next
sense.
question, number 12, says to conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/10. What is the smallest N can be? So now we do the same thing,
Okay.
but we have, instead of 1/2, we have this is 1.
Well, what I was thinking was, anything times 0.5 is going to divide it in half. So anything times 0.1 is going to divide it into tenths, right?
Mhm.
So it needs to be 10 times
Yeah.
that.
I think it's 100.
So 100, yeah.
Yeah, 100. Well, I'm glad I learned that this week.
Right.
Last week when we needed it.
Well, I'm afraid that they might get more complicated and we're going to have to figure out something else.
Probably.
Not, but I'm assuming it will too.
Okay, so let's move on. So number 11 is 20, number 12 is 100.
Okay.
So question 13, or for the water quality study in the reading, about 60% of the microinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance level alpha equals 0.05 with the following hypothesis. P equals 0.6, P is less than 0.6. They collect new data, and this time N equals 80 and X equals 38. So the conditions, so it's asking us the conditions for conducting a hypothesis test are satisfied. So let's plug our numbers in.
So X is 38, N is 80.
Is it a greater than test?
Our null hypothesis is 0.6, and then it's going to be type of test is less than.
Right, because the alternative hypothesis is less than 0.6.
Yes. So our little requirements test, it is true. They're both over 10.
Right.
P hat number 14 is 7.5. As shown on our 475 as shown on our Excel spreadsheet. The test statistic is negative 2.282. And the p-value is 0.011.
Okay.
And so what is our decision? If the p is low, we reject the null.
Yeah.
It is lower than 0.05. So we reject the null. And then number 8, which of the following best summarizes the conclusion of the test? So there is sufficient evidence to conclude that the quality in the area has decreased. So that is, there is sufficient evidence to conclude that water quality in the area has decreased. So that's number 18.
So C.
We said D?
Yeah.
Okay.
Okay, D.
Okay, let's go through real quick and make sure we have all the answers together.
Okay.
Okay, number 3 is P, the normal P. Number 4 is true. Number 5 is true. Number 6 is 0.750. Number 7 is 0.110. Number 8 is 0.640. Number 9 is 0.860. Number 10, we put decrease. Number 11 is 20. Number 12 is 100. Number 13 is true. Number 14 is 0.475. And number 15 is negative 2.282. 16 is 0.011. 17, we reject the null hypothesis. And 18, D, there is sufficient evidence to conclude that water quality in the area has decreased.
Cool.
Okay, let's see how we did. Hey, look at that.
100. Yay.
Good job.
Okay.
Good call on
Cool.
that decreased.
Yay. Okay, I have a quick question.
Go for it.
So, to figure out the type of test that we use in Excel, do we use the alternative hypothesis?
Yes.
Okay. Cool. That's my only question.
Sweet. Okay, So let's figure out this find the study direction.
All right. So I looked at it and it doesn't look so bad. It is really long though. I think it's just a lot of putting in our ideas.
Okay.
Okay.
So that's pretty much all we have to do.
Yeah, we have to list who we are,
Okay.
who assign who the main writer is for each part of it. And then create a question. And ours would be something like, does the age of men who are the heads of households differ from different parts of the country in 1940 or something like that?
Sounds good to me.
Yeah.
And then they want to know what our population is, what's our experiment unit, and our variable.
I'm trying to pull up the document. My computer will load everything but this page.
Oh, I'm sorry. So maybe what we should do is share it. Share one copy.
Yeah.
Okay.
All I've done to mine is plug in our names.
Okay.
Do you want me to share my copy?
Sure.
Yeah, that's fine.
Okay. I don't know why, but for some reason my husband's on all of these. Like every file I have, I'm like shared with Matt Garrett, so he's going to be on there. Well, I can figure out how to do that. Okay, I'm sending an email now. So that way, whoever needs to can add things to it, and then we'll all have the same copy.
Okay. And is this on a shared drive you sent to us?
No, this is Google Drive. It's a shared document
Okay.
online.
Yeah, sorry. I was thinking of work. We have a shared drive there. Google Docs. So cool.
Sorry, I put everything on Google Drive. As soon as I get an assignment, as soon as I open it up, I put it in Google Drive. So I don't think about the fact that other people might not be doing that.
That's a good idea.
Well, I have to jump between two different computers sometimes.
I do that. I do like 4 computers. So
Really? Wow.
I have a laptop. Then my girlfriend has a Mac desktop. And then I had to buy a Windows desktop for my Excel class, which I bought like a cheap, just like from a guy on Craigslist that
Nice.
basically runs. And I have it hooked up to her TV. So
Nice.
So there's 4 of them, and so I'm always like emailing it to myself. So Google Doc makes tons more sense.
It's so helpful. So helpful because then I can go down to my mom's house and I don't have to take anything with me. I can just pull it up on her computer.
Okay. So Davina, do you want to put your name in for the main writer for designing study? Because you pretty much came up with the idea.
Okay.
Or do you, I mean, any of us can do it, but it sounds like we have to.
That's fine with me. And then
We all
If you
collect
guys-
the data.
okay.
And how many names do we need?
Well, we want to have a sample size of 30, right? So that it can be normally distributed.
Yes.
Mhm.
I don't know if I'm going about this the right way, but my thought was to flip a coin, or not flip a coin, but go online because they have a random number generators,
Yeah.
and just have them pick us a random number between like 1 and 20, and then start with that document number in Family Search. So, you know, when they give you a list of records to search, you pick the one that's that number, and then you do the same from then on. So if you get the number 5, you start with the 5th document, and then you count another 5th, and then the next 5th, and keep going until you have 30 samples. Make sense?
Oh, okay.
Yep.
There are 30 names.
Right.
Okay.
And you don't even need to know the names. You just need to know how old they were.
Okay. Yeah, that sounds good.
So make inference. I forget what that is.
If I scroll on the screen, does it change the screen for you guys?
No. Only if you type in things.
So do we have to fill this whole thing out
Yeah,
for Saturday?
I think so.
Okay. So make inference. Let's see.
I think that's, we decide what it means or what the,
Yeah, I'll find out. I'm pulling up the textbook real quick.
okay. I'm thinking maybe whether or not our null hypothesis is true, something like that.
Yeah, so let's see.
Oh, there are 5 jobs here.
Yeah, there are. So make inference. Inference is the process of using the information contained in a sample from a population to make a general statement, to infer something about the entire population. Later in the course, we will learn techniques that make this type of analysis possible. So let's look at the week that we do, because this is going to be an ANOVA, right?
I think so.
That's what I'm thinking too.
Yeah. And I don't know if that's something we have to decide, but that's kind of what I feel like it's going towards.
Because we're going to have 4 sets of data.
Right.
So let's look at this, what this says, because usually they have the design the data and then collection and then summary.
Hey, Kelton, are you looking at the Google Doc yet?
I'm not. I'm sorry. Everything's slow for me.
No, that's okay. If you open up that email, you can see what we're talking about.
Okay.
So QQ plots indicate that it is reasonable to conclude that the data are normally distributed in each group. The largest variance is not 4 times the smallest. So we conclude that the variances are equal to the 3 groups. So that's going to be our an inference.
Oh, so whether one group is different from the others.
Yeah, so it's going to be, yeah, it's it. Exactly.
Okay. So here's a thought. What do you think the make inference and take action sections are going to be a little bit easier? Should we have the same person do those 2?
Yeah, let's do that.
And then have the other person do PowerPoint?
Yeah. Yeah, I think that's a good idea.
So Kelton, do you want to make inference and take action or do the PowerPoint presentation?
I can do inference.
And take action?
Yeah.
You do 2
Sweet.
sections, but I don't think they'd be that hard.
Well, the make inference will be
Just
pretty.
Okay.
And if Suzette has a big problem with that, we can adjust things. We're basically just getting
Okay.
right?
Mm-hmm.
What is Suzette's last name? Is it Penrod? I don't think that's right.
Conrad.
Conrad. I think I was guessing. So we all have to do a write-up on collect the data, and we all have to do a group evaluation.
Okay. And that's for this week, right?
I guess so. Well, here's a note. It says, after you've designated which members are in charge, submit the document.
Yeah. Oh, your project must be approved by your teacher before you can collect any data.
Oh, yeah.
So we just need. So do we just need to fill in the design the study?
Well, this whole thing is design the study.
Oh,
This
this whole
is-
thing is design the study.
Yes, this is all just the first step.
Oh, holy crap! Holy crap!
But it's really not that bad. I mean, after looking at the questions,
Yeah, I guess it's not that bad. What populations are you studying? What is your experimental unit? What
right.
is your variable? Okay.
So I'm thinking, state your research questions. There's Kelton. Okay. So we're on number 1 under design the study, or you're on number 2, Kelton. I see your cursor, but we're on number 1. There you go.
Okay, I see.
Okay. State your research question. I was thinking like, is there a difference between ages of men, heads of house in the 4 regions in 1940 or something like that?
Yeah.
The difference
Okay.
in mean ages? Mean ages? So we're studying men heads of households, right?
Yep.
Okay.
In the US in 1940. Smallest entity?
Human.
Age? An age of I don't know. Person, age.
What is your experimental unit? Yeah, I think age is right.
Okay.
We're experimenting the age.
Response variable, we're not doing an experiment. We're just, well, we're comparing data.
Well, so basically our null hypothesis would be the mean ages of heads of houses in the 4 regions are equal.
Right.
Alternative would be at least one of the mean ages of men heads of household in the 4 regions is different. So
Okay, so the age differences.
Yep.
And then it's quantitative because we're talking about ages, not like whether or not they're black or white or male or female or.
Okay.
and that kind of gives us the answer in number 6.
3 or more samples.
Yep.
Okay.
And then what are your null and alternative? Okay, so jump the gun on those. So
Okay, so not. Well, no, that's not even it. It's that all are the same.
yeah, so The HOUD is the mean ages
at least one mean age is different. Others? All right.
Okay, design the sample. Which sampling method will your group use? A systematic sample, cluster sample? Refer to lesson 2 for specific methods.
I want to say ours is systematic.
Yeah, I think so.
So random starting point and collect every kth sample. Is that something like that?
Yeah.
Yeah.
Okay. Up to 30 samples from 4 regions.
Yep.
Okay.
How are we going to collect the data?
Okay, we will search census records from 1940 for heads of house that are male and collect their ages from every kth record after a random starting point.
Should we put in there somewhere the county?
Oh, we will select our home counties and randomly choose records from them.
Perfect.
That okay?
That looks good.
Yeah. And are we using the family search or like the family search website or just?
Yeah.
Yes, family search website.
It's super simple doing it that way. You can even, yeah, it's cool because you can like export the data into an Excel file and all this stuff.
Oh, okay.
Super cool.
Cool.
Well, I got the idea because my friend Rebecca is majoring in family history, and this was the kind of thing she had to do.
Well, that's cool.
Yeah.
Okay.
So it's asking us what the requirements are. So what are the requirements for an ANOVA is that the data are normally distributed in each group and the variances are equal for each group. Know that until we collect the data, right?
I'm not sure about the variance thing. All variance. Between which- I guess we'll find out once we collect the data.
Yeah.
Okay,
Well,
and
our
I think number 2,
human subject. No.
I think we both know.
Posthumously. Sorry, you think the number's what?
No, I think they're both no. We're not conducting a survey.
Oh, sorry. Yeah, I wasn't thinking straight at the moment. Okay.
We get to skip 14.
Okay.
Fifteen is, we don't have to do that. And then number 19, we have to sign.
All of us.
Do we literally have to sign or?
I think we just have to write our names. Go for it.
And
Okay.
Sweet.
cool.
So now we just need Suzette to go ahead and throw her name on this, and then we can submit it.
Yeah, awesome. That was a lot less painful.
Yeah, that was
Okay.
pretty.
There's an appendix. What is that all about?
That's that's for the survey.
Oh, okay.
We don't have to do that because we're not doing a survey.
Interesting. So glad we're not doing a survey.
That's intense. You have to like get everything approved because I guess there's legal stuff involved.
Oh, yeah. Yeah. I mean, I thought about standing at Walmart asking people questions.
Yeah, I'm glad we're not doing that.
Yeah, me too.
Well, cool. So we just need Suzette to sign this, and then we're good to go, right?
Right? Okay, so I will.
Awesome. Well, okay. Well, are we good tonight then?
I think so.
Yeah, and only one person submits it, or do we all submit it to the teacher, or?
Well, since this is my section, I probably should submit it, right?
Yes.
Yeah, as soon as Suzette sends it. Okay. And then we can't collect data until we get approved from the teacher, right?
Correct.
Yeah.
Cool. Awesome.
And if you guys have any issues, let me know.
Okay. Cool. Well, thanks.
Sounds good.
Have a
Luck.
good night, guys.
Have a good night. Thank you so much.